Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 10F. My name is Siddhi Auti and I'll be your moderator for this session. On the behalf of Global Knowledge and Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025. The ninth edition of the conference is being held in a hybrid mode. The physical event was conducted the day before yesterday, and the virtual events are being held yesterday and today via Zoom meetings. I hope you will enjoy this knowledgeable and interactive session throughout the day. In this session, in total, we will be having 10 presentations. Each presenter will be given a time span of 8 minutes for the presentation and 2 minutes for question and answers. After completion of 8 minutes, I will be raising a gentle reminder since we have a time constraint. Also, there is another request to all the participants that you stay connected with us till the closing remarks. If you face any issue or query, you can write it to me in the chat box. Now, just before we get started, I would like to introduce you all to today's session chairs. The first session chair is Dr. Kalpana Naidu. Dr. Kalpana Naidu is an assistant professor at NIT Warangal, India, specializing in wireless communication, 5G, 6G networks, and cognitive radio. Her research focuses on AI and ML algorithms, heterogeneous communication, NOMA in wireless networks, signal processing, UAV communication, and wireless sensor networks. Welcome, ma'am. Thank you so much for chairing this session. And
Yeah,
along
thank you to you also.
And along with Kalpana ma'am, we have another session chair joining us today. Dr. Aneri Kilon Pandya is an assistant professor and is an assistant professor at Charotar University of Science and Technology, Gujarat, India. With over 13 years of academic experience, she specializes in IoT, microprocessors, microcontrollers, and metamaterial antenna design. She has contributed significantly to research, publishing 20 papers in reputed journals and conferences, and is dedicated to advancing innovation in embedded systems and wireless communications. I also welcome Dr. Aneri in today for sharing today's session. Thank you so much for joining us today. Now, without further ado, we will continue with our participants. So, the very first participant we have here today is Arisetti Satyanarayana Monish from Amrita Vishwa Vidyapeetham. And the paper title is A Rack-Based Framework for Smart Travel Itinerary Generation. I request Arisetti sir to please start with your presentation. Please give me a response if you're there in the meeting. Sir, you are not audible. I think you're trying to say something, but I can see your video, but I cannot hear you. Hello?
Hello.
Now, yes. Now we can hear you. Sir, you can start with your presentation.
Yes, ma'am. Ma'am, let me share my presentation.
Yes, yes, sure.
Ma'am, is it visible? Hello.
Not yet. Not yet. It's not visible. Try sharing it again. It
Uh,
is visible now.
oh, thank you, ma'am. Sorry for the inconvenience. Good afternoon, everyone. My name is Monish, and thanks for the ICTS conference for giving us a chance. Now, our project is a rack-based framework for smart travel itinerary generation. And these are teammates and our guide. We have processed this project in our computer science engineering through Amrita School of Computing. Thanks for the university and thanks for the conference for giving this opportunity. And while coming to the project, first, like today, like I want to highlight some of the things. So now it's going on the world. So today the population was increasing. Everyone want in the world to go share everything in the all over the world to see every places in the world. They want to extremely travel and everything. Today, like I want to highlight some how the travel industry is booming like never. Like everything, tourists now expect more than just destinations. Also, they seek some tailored interests which are going around in the mind by seeing some of the reels and some of the exposure in all over the world. So, using this, we want to expose this all the world. Some of the technologies have to show to them. So, I like there were some cutting edge technologies like RAG, secure API key integration, which are coming into the play into this world. So, like by combining these powerful language models with real time and travel databases, like we can deliver high personalized information. So, from the best local cuisines to hidden gems of the tourist map, every better our system stay context aware. If a major disrupts happening here and there, a location accessibility also, the itinerary instantly adapts, offering nearby attractions or suggesting alternate timings. And coming to the next slide, like many people today love to travel, but find travel planning overwhelming and time consuming. So our project solves by using RAG and API to generate dynamic day-wise itineraries tailored to user preferences, like offering smart real-time recommendations for sightseeing, dining, and leisure also. So for this, a large data set we have needed. So what we have done, we have collected travel data from like sources like Wikipedia, Holidify, and Booking.com, using web scraping tools such as Selenium to gather rich location-specific information. What we have done, after scraping the old data, the CSV files was cleaned using some NLP techniques that structured and indexed with pandas for efficient retrieval and analysis. And so that after that, like what we are done, these docs and CSV file extract consists like 512 word chunks with 100 words overlaps to preserve context for more accurate recommendations to extract consistent and structured travel data. And after that, we have done some embedding them, which is very important for this. So we use some sentence transformer with the embedding 001 like model to generate high quality, low latency vector embedded for travel related content. Like by encoding the data into advanced vector representations and using Euclidean distance or Manhattan distance, we efficiently retrieved the semantically similar information. Like to support this at scale, we integrated everything into the Chroma DB, enabling the fast and accurate retrieval of relevant travel data within our RAG pipeline. So, after that, we indexed some of the process travel into FAISS. Then we use FAISS like it is like Facebook AI similarity set to store and search through the travel related data we process. FAISS is a powerful tool designed to quickly find items that are most similar to give an input. Think of it like a super fast search engine that works very efficiently when which makes a vector representations very fast retrieval. So first of all, what we have done, like indexing the travel data, like after all getting the data from the web scraping, we use some of the model like what we have discussed before, sentence transformer. We store these embeddings in the FAISS. Each of the embedding represents a piece of travel information like a description, like hotel, spot, hotel, or activity. After that, we use like nearest neighbor search, which helps the most relevant travel recommendations by comparing how close different embeddings are from the query to each other in the multi-dimensional space, known as nearest neighbor search. Like after that, we optimize distance matrices and indexing also. Like we fine-tuned distance matrices using Euclidean and indexing strategies like IVF or in FAISS to make the search more efficient and accurate. This means we customize how FAISS measuring the similarity and organize data for the fast retrieval. After that also, there will be a large data set retrieving a lot of every time. So we'll get some problem in retrieving the slow. It will make slow. So what we have done, we are taking the top K retrieval, which instead of retrieving everything, we use top K retrieval, which gives only the top K relevant documents. Like out of 20, we can get the 5 and 10, which are nearly close to the output. And next, going to the next slide, see this is our graph, like user, like me asking a question. After that, it will go to the our Chroma DB and the text process in the chunks, indexing, and embedding from our real database, it will go. So after that, this and our documents on the query will come to the LLM query like a AI generator, and then it will to the answer. And while coming to the results, like first we'll discuss like precision. Like precision helps as how accurate our travel recommendations are by like showing the proportion of relevant results out of all the retrieved ones, ensuring users see mostly useful like suggestions, like most useful suggestions. And while coming to the recall, on other hand, checks whether we are retrieving all the important travel documents or not, making sure no valuable information is left out of the recommendations. Like while coming to the AI generated versus RAG based generator, so like information accuracy and relevance coming to the like RAG based travel plans offer high factual accuracy by retrieving the real time reliable data. Like while AI generated plans may include some outdated or some of the details due to limited pre-trained knowledge. While coming to the consistency and personalization, which is very important, like RAG-based systems can personalize in itineraries based on the user performance, user preferences, right? And location-specific metadata, like unlike traditional AI plans, which often tailored recommendations and may mix attractions from different regions, and easy of updations also. Like updating a RAG-based travel system is simple. Just add in new documents to the retrieval databases. Where I
Sir,
coming to
sorry for the interruption, but we are past the presentation time. Can we please conclude it?
yes, ma'am. I can. Okay, I'm sorry. Okay, like main thing is like to take the system to the next what we have done is like we built a RAG based system that combines real-time information retrieval with language modeling to deliver personalized travel recommendation by using web scraping, document chunking, FASS indexing, and embeddings. We use accurate and location specific results. This dynamic retrieval from trusted sources significantly like improved the system's accuracy, reduced AI generated hallucinations, and enhance the overall factual reliability of the recommendations. And thank you, ma'am. Thank you so much. Hello.
Uh, Thank you so much, sir, for the presentation. Are there any questions by session chairs, or shall we proceed?
Yes, ma'am.
Yes, good afternoon.
Good afternoon, ma'am.
The question from my side is, how does your framework compare with the existing travel attorney planners?
Ma'am, actually, see, ma'am, now ma'am, we use some indexing like what I told, like BM25. Ma'am, like while coming to the others, like they directly use the API integrations. While coming to after API key integration, every time we cannot get the all information. For example, like what is like, ma'am, for example, we want the flights from the Kerala to Jammu and Kashmir. We using API integration, there will be no flights because there are no direct flights, so it cannot give. While back model and we have like indexing embedded, we get a good conclusion, ma'am. From Kerala to it gave to Delhi, and from Delhi to it given to like Kashmir. So from this we can understand how much accuracy ours. Yes, ma'am.
Okay. And what are the limitation of your approach? Are there any limitation?
Ma'am, because tourism is not a small thing, a large network. It's come from apart from various countries. Nowadays, they're getting a new places, and they're constructing a new tourist places. So we adaptability have to be more, and the databases have to be long enough to store everything. So we have to train very well to get accurate personalized information.
Okay, thank you.
Thank you, ma'am. Thank you so much.
Thank you, sir. Now we'll go on to the next presenter. The next presenter is Vijay Sharmila from Loyola ICAM College of Engineering and Technology. Sharmila ma'am, if you're there in the meeting or any of the co-authors are present, please let me know and give respond to this. If not, then we'll have to proceed further. Okay. Do we have MD Sohail Rana from Northern University of Business and Technology, Khulna, Bangladesh? So the next presenter is Shazia Fatima from Shri Vishnu Engineering College for Women, India. And the paper title is Color Analysis and Classification Based on Deep Learning Techniques. Shazia ma'am, I think you have joined the meeting. Can you
Yes,
please
ma'am.
continue? Yes.
Yes, ma'am. Thank you for this opportunity. Good morning, everyone. I am Shazia Fatima, and I am here to present our project titled AI-based color detection system using deep learning and computer vision. This system is designed to detect and announce colors in real time from images, videos, and live webcams, bringing accessibility and smart computing with AI. Ma'am,
Hello.
let me share my presentation.
Yes, ma'am, you can share your presentation.
Okay, ma'am. Is it visible, ma'am?
Yes, it is visible.
Okay. Um, this project addresses the challenge of color identification for visually impaired individuals and smart applications by combining traditional machine learning models like KNN with neural networks and integrating it into an interactive systems using Flask. We have developed a tool that is accurate, responsive, and real time. Color plays a vital role in communication and understanding. However, for visually impaired people or in automated systems, recognizing color is challenging. Our objective is to build a system that detects and speaks the name of the color from various sources using AI, making technology more accessible and practical. We have studied various models used for color detection. The research spans from basic RGB threshold to deep learning approaches. Most systems lack real-time performance or interactive interfaces. We chose a hybrid model, KNN for its simplicity and ANN for its learning capability to bridge the gap, ma'am. Coming to the problem statement, our project aims to solve the challenge of accurately detecting colors from images, videos, and live webcam feeds using AI. This is harder than it seems due to several real world issues like lightning variations. Color appears differently in sunlight versus shadow or indoor lighting. Camera differences, real time requirements, color similarity, like many colors like sky blue and cyan are hard to distinguish. The key issues were difficulty in color naming under different lighting, accessibility for visually impaired users. So we designed a system that handles all these challenges using AI and supports speech output for accessibility. Our objectives are to build a system that accepts input from images, videos, or webcam and detects the clicked color, names it using a trained model, converts the name to speech, and works in real time through a user-friendly interface. We followed a clear pipeline, collected color label data sets, pre-processed the using OpenCV, trained hybrid models, developed them using Flask, added real-time interactivity and speech output. All components were developed in Python itself. Coming to system architecture, this diagram shows the workflow. Like input comes from webcam, video, image, and coordinates of mouse clicked are tracked. RGB values are extracted at that point. The hybrid model predicts the color name, and GTTS, which is Google text to speech, converts it into the speech. The result is displayed and spoken instantly. Coming to the modularization, our system is modularized into data acquisition, in which we use the Kaggle data sets labeled with color names, use NumPy and OpenCV to clean and normalize data, and hybrid KNN plus ANN model for better accuracy for model development. And for metric evaluation, accuracy and precision were tested under different lighting and built on a Flask with a smooth user interface. And the frameworks we use used are Python, OpenCV, Flask, GTTS, YOLO. We use the curated dataset from Kaggle that map RGB values to common color names. It contains over 500 plus labeled colors. We split it into a training and testing subsets, ensuring the model learn both basic and complex color variants. We have experimented with both KNN and ANN. KNN uses the nearest RGB values, while ANN learns the patterns in RGB space to generalize better. We found that combining both improved performance in edge cases like in dim lighting and or mixed colors. We use the accuracy, precision, and recall as metrics. The hybrid model achieved higher precision in ambiguous color regions, like we have also tested under different environmental lighting to ensure the model reliability in real time. Technologies we used are Python as core language, OpenCV for image or video processing, Flask for deploying our web application, GTTS for converting text to voice, Matplotlib for visualizations. Coming to the results were promising. Our model detected over 90% of colors correctly in all input modes like images, videos, webcam. The speech output had maybe less than 1 second delay, and the user interface was very responsive. Users could also get instant color feedback by clicking on the particular color. These screenshots show real-time detection from each module, like image for video and for live webcam. The pointer follows the mouse and announces the detected color dynamically. This system can be used by visually impaired individuals to understand surroundings, designers or artists for color analysis, educational tools for teaching colors, and robotics for or smart devices that need to be precise color context. And it may also be used in traffic systems for colorblind users. And coming to the limitations in our project there are some challenges like inconsistent lighting affecting color accuracy. Colors outside the training data set might be misclassified, background blur or motion in webcam. Uh, they can use YOLO and attention models. In summary, we built a smart real-time AI color detection system using deep learning and computer vision with application in accessibility and automation. It is scalable, fast, and interactive. So future scope is we plan to integrate detection like YOLO to detect and color classify specific objects, build a mobile app or hardware mobile module for broader impact. Thank you for your attention. I'm open to questions and feedback, ma'am.
Thank you, ma'am, for the presentation.
Okay, the question
Thank you,
is,
ma'am,
what
for
are the
giving me this
real world
opportunity.
application? Hello, am I audible?
Yes, ma'am. Yes, ma'am. Yes, ma'am. You are audible.
I want to know कि what are the real world application of your color classification technique?
Okay, ma'am. Like we can use this in uh, traffic light systems. Like there are some colorblind users who can drive cars and they don't know which color is which signal is displayed because all there are three types of colorblind users like protanopia, ditonopia, and tritonopia. So by using this application, they can get to know which signal is shown, and they can use in educational tools for helping children and students learn color names and properties interactively. And in surveillance also we can use, ma'am, recognizing specific color-based patterns or suspicious objects from CCTV footage. Yes, ma'am.
And how your model will train when dealing with the complex color patterns?
We have trained the data set, ma'am. Under by using hybrid model ANN and KNN.
Okay.
Yes, ma'am.
Okay. Thank you.
Thank you, ma'am.
Excuse me, ma'am.
Yes.
I'm the co-author of the paper. My paper ID is 780. My supervisor
Sir,
name is MD Shoulder. Now I'm to present my presentation. Can I?
what is the paper title? Can I know the paper title?
My paper title is Analysis and Design of 3.5 GHz Space Antenna for 5G wireless network application.
So you are going to present on on behalf of Sohail Rana, right? MD
Yes,
Sohail Rana.
yes.
Yes. Okay, sir, you can start with your presentation then.
Okay, thank you, ma'am.
Yes.
Is it visible?
Yes.
Good afternoon. I am Al Mamun. I am the co-author of this paper. My supervisor name is MD Shoail Rana. My paper title is Analysis and
Please,
Design of 3.5
please,
GHz Space Antenna
Mamun.
for 5G wireless
Hel-
network application.
Hello, Al Mamun. Please enable
Yes, sir.
editing. Please enable editing.
Sorry.
Enable
Sir,
editing.
please show the PPT in show mode so that people will be able to see it.
Is it okay?
Yes. Yes.
Presentation
Thank you.
slide mode, please. Presentation slide mode.
You can press F5.
Can I continue this space?
Yes, yes, sure, sir. It is visible. You can continue.
Okay, ma'am. Now, past the presentation outline, we see that introduction, methodology, objectives, literature review, proposed antenna design, experimental result, conclusion, and last part is the reference. The next slide, we see the introduction part. In wireless communication system, an antenna plays a vital role. It is a metallic device for radiating and receiving the information in the form of radio waves. A proper design selection of antenna is most important criteria for the designing for wireless communication system. The proposed antenna has two basic goals. The first to improve the return loss by employing a typical voltage standing wave ratio, and the second is to improve the antenna efficiency. Excellent radiation pattern gain ultimately making it suitable for use in wireless application. Next slide, we see the methodology of this antenna design. First, we see the start, then literature analysis. Literature analysis, we can gather some information from the Google Scholar or some information that has been previously worked. Then we can do the antenna design, and with some materials requirement, we use some materials. After that, antenna design, patch antenna dimension calculated by manually. Uh, then we see the assessment of this performance antenna. After the performance, if we can satisfied, yes, then we see the final result. If we are not satisfied the result, we can go to the optimization and going to the again antenna design and get some another material for this antenna to design. Final result, after we talk with our supervisor, we can have a future plan of this antenna design. We goes for the fabrication is the process of creating physical antennas for design using various techniques and materials. After that simulation, we can see the end process. Then we see the objective of this antenna design and simulation of suitable antenna for wireless application. Second, achieving high gain and high power radiated or receiving by the antenna, also included return loss, Bs omega, radiation efficiency, and bandwidth. Next slide, we see the literature review. A high gain microstrip patch antenna, WiMAX antenna that works at 3.5 GHz has been installed to make room for a parasitic radiator and a higher ground plane. Positioning the parasitic radiator on top of the PAS antenna, increasing the gain. This study presents a T-shaped rectangular PAS antenna operating at 3.6 GHz. The properties under discussion encompass radiation pattern, return loss, gain, current distribution, and radiation efficiency. A microstrip component feed line is necessary to supply the suggested antenna with directional radiation. The purpose of this study to demonstrate the design and development of a high gain loop antenna for use in 5G wireless application. It was initially planned for a hexagon pass to have a resonance frequency of 3.5 GHz. Based on this research, I constructed a 3.5 GHz rectangular pass antenna to achieve a gain, a broad bandwidth, and a better return loss from the design. Within the scope of this study, a planar reconfigurable antenna is developed, which is appropriate for various applications. This was done to obtain good bandwidth and standard Vs omega r and reduce return loss. This article aims to provide an ultra-wideband pass antenna that is optimized, compact, and octagonal in shape. It was created for numerous uses, including 5G, Wi-Fi, possibly 6G technologies also. Its high average efficiency, excellent return loss, and perfect Vs omega r make it ideal for such application. Next, we see the main part of this antenna. Here is the two part. First, we see the main four part of the microstrip pass antenna. Microstrip pass antenna has been four parts. First part has ground. Second part has microstrip pass. Third part is microstrip feed line, and the fourth part is substrate material. Then the figure shows the two views. Front view shows the proposed antenna, and the back view shows the microstrip pass antenna. Here is also we see the table. The table shows the parameter with their value. Here is wave ground, wave pass, length pass, etc. Next we see the experimental result. Return loss. The figure 4 shows the antenna design return loss. Return loss means the amount of power reflected due to discontinuity in the path of transmission line. At 3.5 GHz, microstrip pass antenna return loss are minus 43.681 GHz. Figure 5 shows the microstrip pass antenna voltage standing wave ratio. Voltage standing wave ratio means the amount of mismatch
Sir,
between the antenna and
sorry
the
for
feed line.
the interruption.
Yes.
Actually, we are past the presentation time. Can you get to the conclusion now?
Okay, ma'am. Now I describe the most important part of this antenna design. This is the experimental result. This table shows the compares between proposed torque and the published torque. Proposed torque that already we have done, the result has been shown at the table below of this table, and reference 12 to 29 is the published work that has been already published in the another journal that we collected from that result. Here we see the our result at 3.5 GHz mesh antenna return loss has been minus 43.68 decibel. That has been more valuable than Vs omega R is 1.0458. The gain of this 7.8 on decibel isotope, and the efficiency are 89.25%. That is most useful for the antenna design. And this application are used for 5G wireless application. And the last part of this antenna presentation are conclusion part. We learned from this antenna design. A small microstrip pass antenna has been proposed for 5G wireless application. The proposed pass antenna shows optimal VS omega, improve antenna efficiency, excellent radiation pattern and gain, and also to increase antenna performance. Fabrication for publication in journal. In the not too distant future, it will be feasible to fabricate this antenna, test with a vector network analyzer, and then compare the simulation results to the actual results. Thank you, ma'am. Thank you, everyone.
Okay, so you have whatever proposed antenna you have shown, that you have simulated on the CST model. Is it okay? Hello? Hello?
Yes.
So you whatever proposed antenna you have shown, that you are simulated on the CST?
Madam, I am the co-author of this paper for a net problem for Idul Adha. Now we stay home for network issue. Yes, ma'am. Only is designed only CST software, computer simulation technology software.
Okay.
Only
So what substrate as a substrate, what material you have used? FF or Roger or anything else?
Rogers RT5880, ma'am.
Okay. And can you tell me the testing method? You have not tested or fabricated the antenna, but do you know what are the testing method used to validate any antenna's performance?
Ma'am, next we'll try we'll try this design. We'll try fabricate result, and we will also compare the fabricate result and simulation result in future.
Okay, thank you.
Okay, ma'am. Thank you. Any question?
The next presentation is by T. Ekeshwari from Shri Vishnu Engineering College for Women, India, and the paper title is Enhanced Fashion Shopping Using AI and Full Stack Integration for Cutting Edge Trend Insights. Ekeshwari ma'am, you're there in the meeting. I request you to please start with your presentation.
Yeah, I'm there in the meeting from Shivani. I'm audible?
Yes.
Yeah. So is my screen visible?
Yes.
Can I start with your presentation?
Yes, ma'am. Sure.
Yeah, so hello everyone. It's a pleasure to be present here at ICTIS 2025. Today I'm excited to share with you our journey in developing a virtual fashion stylish, a smart and personalized way to reveal fashion recommendations. We all love dressing well, but sometimes choosing the right outfit can be overwhelming, right? Well, that exactly what we aim to solve. So why did we build this? We noticed it that most online fashion platforms either suggest random outfits or rely heavily on trending items without truly understanding what you like. Everyone has unique preferences like style, colors, patterns, even modes. So we thought, why not build a system that tailors recommendations specifically for you? So how it exactly works is, let's walk through the simple steps of our how our virtual fashion stylists work. So first, the user have to register into the system or the website what we have developed. You start by signing up and filling in your basic details, and then you'll be getting the preference selections. Like you tell us your style preferences. Do you like casual wear, street style wear, or something more formal? Then you have to submit the preference list. Once you submit your choices, our system gets into work. So based on your input and browsing history, we suggest outfits that match your taste. So now let's uh, talk about what makes this system work. We explored multiple machine learning techniques and finally settled on a hybrid recommendation model, which combines content based filtering. It analyzes item features like color, fabric, and occasions to match your preferences. We have used content based filtering, collaborative filtering, and deep learning for our model training. So, I want to discuss that the challenges that we have faced and how we overcame them. Of course, this wasn't a walk in the park. We had challenges like what if a new user had no past data? we tackle this using initial preferences surveys. So, and also the trend adaptability. Fashion trends change fast. We incorporated real-time trend analysis to stay updated. So the limitations of our project is our model performs best on trends and styles included in our data set. So we have used uh, a data set from the Kaggle that includes the data about the users' preferences and the colors or their choices in fashion. So while coming to the conclusion, a our project is all about a virtual fashion stylish, a platform designed to make fashion choices easier, more personalized, and fun. Thank you all for your time. I would like to hear your thoughts.
Okay, so question from my side is, how does your system integrate with the e-commerce platforms?
So you're asking about the integration, how we have done the integration with the like the website and the recommendations.
Yes, yes. Hello.
Hello, am I audible?
Yes, yes.
So we integrated the website and recommendation system using a REST API architecture, ensuring smooth communication between the front end and back end.
Okay. And
We have developed this using Python. Yeah.
okay. And what is the accuracy of the trend prediction?
So when it comes to the accuracy and all, so for the content-based filtering alone gave an accuracy of 72%, but it struggled with new users. So when it comes to the collaborative filtering using singular value decomposition achieved 78% accuracy, but required a large user base to be effective. So we thought of using the hybrid model, and we have implemented that in our model. So the hybrid model gave the accuracy of 85% in recommending relevant fashion items.
Okay, okay. Thank you.
Thank you, ma'am, for your presentation. Now we'll go on to the next one. The next presenter is Priyadarshini Rajasekaran from SRM Institute of Science and Technology, and the paper title is Enhanced Waste Management System for Smart Cities. Ma'am, you're there in the meeting, right? Give us a response or start with your
Yes, ma'am.
presentation. Okay.
Is my screen visible, ma'am?
Yes.
So good morning, all are present here. So myself, Rishni, along with my co-authors, Gagan and Shivam, presenting a work on enhanced waste management system for smart cities. So this is the outline of my presentation. So urban waste management is increasingly becoming a public health and environmental concern. So the traditional methods that are available are inefficient and costly. In contrast, we are proposing a smart waste management system that uses sensors technology to streamline the collection and disposal of waste, ensuring a cleaner, safer, and more sustainable cities.
Hello. Ma'am, is there an issue because you've stopped sharing your screen? Hello.
Hello, ma'am. Am I audible, ma'am?
Yes, yes.
Is visible, ma'am?
Yes, ma'am. Please continue. Your screen is visible now.
Okay, ma'am. So the prime motivation of the work is that the inefficiency in the current waste segregation system. So if we see where there are overflowing bins, and even if we have different types of bin for different types of waste, the manual implementation is very difficult. So we are not able to segregate into the respective bins. Sorry. So we did a literature survey. So this summarizes the literature, and as a result of the literature survey, on the problem statement to be just the improper waste management system leads to unhygienic environments. So we are going to upgrade the traditional dustbins by using a smart dustbin with different types of sensors to segregate the waste and also to send alert messages when the bin is almost full. So this is based on the needs for this. So based on this, we have formulated our objectives to be developing an automated waste segregation system and improve the waste disposal efficiency using IoT. So here we have three specific objectives. The first objective is to categorize the waste into three categories: wet, metal, and non-metal. So we are using a moisture sensor to categorize the wet waste, and a metal sensor, inductor-based metal sensor to categorize the metal waste, and a basic IR sensor for categorizing the non-metal waste. And then we are using an ultrasonic sensor to detect the bin level, and when the bin is almost full, it will send notifications. So for sending the notification, we are using a GSM module. So this is what is the overall system model. So instead of this, so this is what is the dustbin that we are going to propose. So inside this, we have two different levels. So here we have a top bin. So inside the top bin, the waste will be put, and based on that, so in the top bin, we have this. So first we have a UV sensor, that is the ultraviolet sensor, is used to detect the level of the bin. So when the bin is almost, it will be sending notification by using the GSM module. And then here we have a motor. So here we have a slider or rotator which is controlled by the motor. So here these three sensors have IR sensor is used to detect a non-metal dry waste, and a metal sensor to detect the metal waste, and a moisture sensor to detect wet waste. So depending on this input to the sensor, the respective waste will be identified, and accordingly the motor will be rotating. So once the motor rotates, the slider or rotator will be moving, and the respective bin will be opened so that the waste is segregated. So these are the system specifications. So for that we used, so this is based on an Arduino microcontroller, and then we have different types of sensors. Then we are having a servo motor and software for integrating Arduino. We are using Arduino IDE programming, and then sensor integration and signal processing. And for sending the information, we are using GSM based notification system. And these are the different types of sensor that we used: ultrasonic sensor, IR sensor, metal sensor, moisture sensor, and then GSM modules. And the working principle is based on, first they're going to place a based, so this was the flowchart of our working principle. So here we are going to have a bin. So the waste is put into the bin, and once it is put, so first the sensor will check, the ultrasonic sensor will check for the level in the bin. So if the bin is almost full, then the waste is, so the notification will be sent to the GSM module. And if the bin is not full, then it goes to the next level where you have different types of sensor: metal sensor, moisture sensor, and IR sensor. So if the metal sensor detects a metal waste, then the servo motor rotates accordingly, and we have different colored bins to differentiate different types of waste. So yellow color bin represents the metal waste, and blue color one for the non-metal waste, and red color one for the wet waste. So if a metal waste is detected, the motor rotates and the bin will be open. So that waste will be going into that yellow bin. And similarly, if a wet waste is detected, that will go into the red bin. And if non-metal waste is detected, that will go into the blue bin. So once it is done, again it will check for waste disposal. And we have done the simulation by using Proteus. So this is what is our model diagram. We have a Arduino Uno ultrasonic sensor and a display to show the what is the progress. And then here we have a GSM module and then and motor. So here for the simulation part, we didn't include the sensor and the moisture sensor. We basically simulated using the ultrasonic sensor. And then, so this is what is the results we got for this. So we got an accurate waste segregation, the type of the detect. So whatever we have used some thresholds for detecting metal waste and then wet waste. So based on that threshold, we said the correct type of waste is detected. And then here the distance is what is the output from the ultrasonic sensor. So we'll have the height of the bin, and based on that, this distance will show how much of the bin is full. And once the bin is full, we are sending notifications using the GSM module. And this is what is the hardware implementation. So this transparent bin represents the top part of the bin.
Hello,
So
ma'am,
yes,
sorry for the interruption. Can we please get to the conclusion? We are past the presentation time.
yes, ma'am. As I present, and better frame of the accordingly, we can see the bin. The first one for the wet waste, and second one is metal waste, and the third one is for non-metal waste. So accordingly, the bin rotates, and then we are able to segregate the waste. And once it is full, the waste bin is full, the notification is sent to the GSM module. So we are able to segregate the waste without manual intervention, and the notification will be sent to the respective person so that we can avoid the overflowing of bins. And so not be able to differentiate between waste with different types of waste, that is not here. So we can improve like that, and then we can integrate AI for enhanced testing. So these are the references. So that's all.
Okay, so you have designed a system using Arduino Uno.
Yes.
Yes, and you have connected some sensors to the each of the bin, and based on that, you are detecting the waste in the bin. Now the question is, how much total power
We have
supply?
a top. The power so now working.
Hello,
Hello.
hello.
Ma'am, am I audible, ma'am?
Yes, you are audible.
So for practical implementation, as for us now, for a prototype, power is not an issue. But while we go for implementation, we can use solar panels to improve the power efficiency.
Yes, because if you are talking about the scalability option, you
Yeah,
are going for the scalability and developing this solution across the multiple cities, then you have to consider the power supply.
yes, ma'am. For a prototype, this is fine, but for the actual real-time implementation, solar panels will be efficient option.
Okay, thank you.
Thank you, ma'am.
I'll go on to the next presenter now. So the next presenter is Chitran Pokhrel from Tribhuvan University, Nepal. And the paper title is Photonic Quantum Router Repeater Architecture-Based Network Design for Urban Environments. I request you, sir, to please start with your presentation.
Am I audible now? Excuse me?
Yes, yes.
Okay. Okay. Yeah. Okay. Okay. Hello, everyone. Thank you for letting me present this topic on photonic quantum router repeater architecture based network design for urban environments. This is supported by University Grant Commission Nepal, and I'm here to present it on behalf of the principal investigator. So, moving on to the quantum communications, what it does is that it leverages the quantum mechanics principles of superposition, entanglement, and no cloning theorem. However, this communication does not come without a challenge, and the major challenge remains with the transmission of quantum state that is restricted by severe signal deterioration. And when it comes to dense urban environment, it is amplified. Therefore, designing a router repeater architecture which utilizes the repeater functionalities within the router nodes has been proposed in this paper, because putting on the traditional repeater architecture with or the legacy repeater architecture with urban environments is not cost feasible. So as we move on, the major questions are: what are the primary factors that affect the performance of this network, and how effectively do the router repeater architecture based network perform under the urban environments, and can it be something insightful for the future implementation of quantum communications? The major research objectives are as shown. So coming on to the background theories. So mainly the three major related works are with Zweger, that worked with noise tolerant communications measurement systems. And then we have the IQNet that was deployed in Chicago, also with high efficient cavity, also with the other work with quantum memories, as we can see in the slide. So coming on to the router repeater architecture, what it does different from the routerless repeater architecture is that it, rather than establishing or requiring an average succession probability of one entanglement generation before succeeding, it establishes the link with the adjacent node beforehand. So what it does is that with a single atom memory, as shown in the figure, with a single atom memory where electron spin is used as the broker qubit due to its fast manipulation and strong interaction with external fields, and nuclear spin is preferred as storage qubit because of its long coherence time and stability. So this architecture beforehand establishes the connections with adjacent node rather than requiring a success probability of one entanglement generations in attempt before succeeding. And the algorithm for the entanglement generation and for the router repeater architecture is as shown in the slide, where the link layer entanglement is established beforehand. So upon working with this architecture with SPDC based entangled photon generations, as we can see that even in a simulated environment, this method has the SPDC method has been able to generate highly entangled photons, which can be seen with the Wigner distribution of the negative peaks, which results into the quantum correlations as well as the parameters shown in the table. Now, when we come into the dense urban environment, the base loss is more. So that has been modeled accordingly, considering the environmental loss as well. So with a 3-node test, what we can see is that the relay node or the second router that remains in the middle in a linear topology is taking time before it swaps or forwards the entanglement to the third router, whereas the continuous generation of the entanglement in the third router can be seen. This middle router's opposite behavior and the sudden and sharp change of memories shooting off is a signature that the R2 is being used as a relay or a repeater, which was our goal. And with this architecture, we have managed to work with a centralized network manager, giving us a similar paradigm to software-defined networking. And with a 5-node architecture in a star topology, what we have achieved is a good fidelity, as you can see with 0.90 average end-to-end fidelity, as we call it. And there is a negative correlation between throughput and fidelity. Now, what this suggests is that we may need to increase the coherence time or the memory coherence to achieve a better fidelity, as well as to balance the throughput of the network. So this is an indication, this is a step towards implementing the quantum networks in future, although this is a simulation-based architecture. So on conclusion, what we have achieved is that we have achieved a good fidelity of 0.908, which exceeds the previous work of IQNet, which achieved around 0.88 of fidelity, which is 88% of fidelity. And the scalability is out there for 3 to 5 nodes, although there are limitations that we need to work with a larger network topology. And this is somewhere we have achieved upper node analysis for quantum memory in urban networks. And with future work, we are trying to test it with a larger network and analyze performance with added noise data that are there. So basically, the noise data comes from the analysis and creation of the photons within the optical cavity, and analyze the hardware impact of hardware efficiencies in the real world testing. These are some references. Thank you. Any queries?
Question from my side is, how does your architecture ensure the security in urban network environment?
Security comes up with the mixed state generations, as we can see with the von Neumann entropy within the within this generation of entangled photons, which is used as a qubit later on. So what does this represent is that it is not very easy to probabilistically determine the states of how these qubits are carrying the information. So that these parameters does actually validate of the security as well. And the other features within the architectures comes from its broker qubit and storage qubit. So when we talk about the electron spin, it's very different to the energy levels that it operates on, and it has quite fast manipulation and stronger action fields. So the establishment is pretty secure. And when it comes to quantum network, the security does not come from computational hardness, rather it comes from the physical interaction itself.
Okay, thank you.
Thank you.
Thank you, sir. Thank you, ma'am. Now we'll proceed to the next presenter. The next presenter is Sabram Patnaik from Amity University, UAE, and the paper title is Real-Time Chroma Key Monitoring, Enhancing Camera Work Precision in Smart Studio Environments. If anyone from any of the co-authors are present, please let me know and respond. If not, then we will proceed further.
What? Sorry.
Hi, ma'am. My name is Sambram. Am I audible, ma'am?
Yes, yes.
Okay. Is my presentation is also visible?
Yes, sir. We can see your presentation.
But I don't know why it's not happening full screen.
Just give it a minute.
Okay. Is it full screen now, ma'am?
Yes, yes.
Okay. I think good afternoon or good evening, depending on the time zones. My name is Sambram, and my paper ID is 845 with my co-author Dr. Sadullah Khan and Professor Dr. Jaiti Sarma. The title of my paper is Real-Time Chroma Key Monitoring, Enhancing Camera Work Precision in Smart Studio Environment. Before I start this paper, it's exclusively I have done for the experiment which has been done inside the smart studio. Now my next research will take place on the outdoor location. So the convergence of digital imagery, animation, sound, and interactive media has expanded cinema's visual and narrative capabilities, offering filmmakers new way to craft immersive storytelling experience. As we are seeing any of these movies, most of the movies is being shot on wherever there is action sequence happens, that is been shot on a green screen. The right side image, which that's only for a reference, or in fact that is our image as well. This is on the top image we shot under the studio, and the right image we given a command to the AI option in Adobe Premiere Pro, which is editing software, that we need a replacement background matching to the foreground, and this is how we get. And previous times, this takes near about a day or half a day time for us to choose which background to be added. So this is how it is. Our paper is, which shows the real-time chroma key technology, which while shooting you can see that how the output will be visible instead of going to the post-production, which is our editing section. And the methodology is this is completely an experimental study we did, and this explores the chroma background removal for optimizing film and television production. This will both work in both the cameras of television as well as the film cameras. And the methodology, we have added that a comprehensive literature review to understand the industry standards, which that is including the recent technological advancements, seamless chroma background removal, and then the tests which we have done in the real world, that is we did in a controlled studio environment under professional lighting techniques for a green screen, and a real-time background replacement, that is using an AI suggested background applied to raw footages, because we shot in raw completely, so that in later on we will have options to change whichever is possible. And analysis of the effects of the shadows, color palettes as well, and contrast and brightness, which is most important in any of these images which we produce. And what is the important of multimedia and film production is, all of us, we know that this is various formats, including the text, imaginary, animation, that is CGI, visual effects, virtual production, where you can see the main character, but whatever happening in the background is all is CGI, and virtual production and advanced editing software. These all are the important for a multimedia in film production. For our experiment, what we did is we will try, first we tried with the trial run, and we found errors with the trial run, that is lighting errors. Wherever we do as any type of film or television production, the lighting is one of this most important parameter for that. And this takes a lot of time for us. And in our trial run also the same thing happened. And we found out uneven illumination on the backdrop. If you can see the backdrop on even illumination, because the light was not harsh and it was creating harsh shadows. And second thing is color spills. If you can see the light, the way the light is beams are coming on, that is the spilling of the colors on the background, that also we changed. And the third one is with the camera related focus. If the subject is moving little faster, it is a bit difficult for us to focus. Autofocus will not work. And the second thing is incorrect exposure. If the exposure is not correct with the 2 or 3 subjects, and then it is another problem which we faced. And in terms of the transferring the footage from the camera to the editing software live, we found the problems with, mainly the problems we found with the threshold. If you can see, this is the 1 2 3 4 times we did this trial, and finally the last trial which we done, that we take as our final output, as there is no more errors were there. In trial 1, the threshold setting was 0.8. You can see that 0.8, which is visible artifacts, but then we did the adjustment and we brought it to 0.4. However, if you can see our threshold settings, the final we got is 0.4, which is achieving a seamless natural image, because what human eye sees and a camera lens sees is completely different. We wanted to bring that much more closer to the human eye. And this is the experiment which we did under the lighting. Before that, this is the sketch, the drawing is done by us. And this is the equipment which we used, the lighting techniques which we used here, that is called a 3-point lighting techniques, and that is the principal modeling of lighting techniques, which all the film and television productions, this is the basic principle of lighting which we use. And this is the placement of light which we did in our studio. And the camera is always placed at 6 o'clock, and the backlight goes as at 11 o'clock, so that it will not come in the camera. And this is the workflow, how it works. And from the main camera out, it goes to the editing software, and editing software we change the background. Then again from there the final output come with a HDMI cable, and then it goes back to the camera's external monitor, in which the camera person and the director can see that how this image will be shown in the final output after removing the background and adding a relevant background. So this efficient workflow seamlessly integrates hardware and software, which is designed and effectively. Our experiment, we established a real-time background replacement. We tried with the real-time background replacement, and with using a Blackmagic cinema camera, and with a 50 mm lens, and it works for us. Then again with the next, if you can see my left side image, this is how the live feed was processed through video editing software. The below image is directly from the camera, the left side image, and the external monitor shows all the settings of the software, that is the OBS software, and it shows that replacing the background, how it would work, how it looks. If the character moves, then obviously the background will remain same, because this is a steel background we have used. It will remain same, and the camera person can see that after editing how it will be looks, so that you will not spend more time for the post-production, as post-productions are much more expensive. So you don't need to worry about the post-production. You can see the live preview how it has been happened. And again, the challenges which we feel with the reflective surfaces, with the surface is reflective and that is coming back, we face those challenges. And second is if the character is wearing the similar shade of cloth which is relevant to your background, that is green in our case. And most importantly, we've faced the problem of the edge of the character, and say about the underarm, the shadows, because the lighting which is being done, that is from a top light it is coming, and probably chances are there that we are getting this kind of error.
Sir,
Yes, ma'am.
sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yes, ma'am. The next slide is, I made this slide. So next slide is that, ma'am.
Yes.
So this is the synchronization chroma key processing tools, that how it will works. And integration challenges also arise. That is the integration when it is traveling. I mean, so when it is transferring the signal from the camera to the editing software. And this is our conclusion. This experiment showcased how real-time chroma key monitoring can streamline workflows. As the film and television industry embraces digital transformations, this research offers valuable insights for media professionals and underscores the importance of ongoing technological advancement in shaping the future of visual storytelling. While again the challenge remains, as I told you, for the outdoor shootings, but however the industrial integration into the film production is already been tested, and it can shape the future of cinematic storytelling, pushing the boundaries what is possible in filmmaking without going to your post-production in terms of where we're changing your background, chroma key background. Yes, ma'am. Thank you. Any questions? I would love to answer.
Good afternoon, sir.
Yes, ma'am.
Can this solution be adapted for the application beyond the video production?
Yes, ma'am, it will be, but it will be again very expensive. Because if you see the equipments which you have used, that is professional film production equipments. And yes, you can do that, but it will be a little expensive to afford.
Okay. And if we talk about the challenges, then what are the major challenges you are facing whenever you are performing this task?
Ma'am, the first challenges is what you are seeing to take this image to coming back the final output. It takes us 7 hours because the lighting is the most critical which you do. Lighting has to be even in everywhere. We use a light meter to know what is the intensity of the light each and every part of the body, and that somehow it was not matching with the output which you are seeing in the computer. That is what we have to change. You have to replace the light. You have to increase or decrease the intensity of the light, as well as if you see there is a little of wrinkles on the chroma screen, the green screen. That also made us another challenges while cutting the chroma key, ma'am.
Okay, thank you, sir.
My pleasure. Thank you very much.
The next presenter is Upinder Kaur from Maharaja Agressan University, India. And the paper title is State of the Art Security Solutions for SDN Based VANETs, a review. I request Upinder ma'am to please start with your presentation.
Yes, ma'am. Ma'am, screen is visible?
Yes.
Good afternoon, everyone. Myself, Upinder Kaur. The title of my presentation is The State of Art Security Solution for SDN-based Vehicular Ad Hoc Networks, a review. With the rise of fifth-generation network technology and swift expansion of vehicular networks, traditional vehicular ad hoc networks encounter considerable challenges in managing large-scale dynamic and diverse environments due to their limitations in flexibility and scalability. To address these issues, researchers have recommended integration of software-defined networking, programmable networking architectures with traditional VNets. SDN improves network flexibility, programmability, and scalability while providing a global view of the entire network. As a result, SDN-based VNets seem to be a promising approach to address current and future vehicular networking challenges. However, integrating the SDN with VNets raises security concerns stemming from its programmability, open flow-based communication mechanism, and implementation of logically centralized control system in the networks. This paper reviews the state-of-art security solutions proposed by researchers in the literature aimed at securing the network operations of SDN-based VANETs. Additionally, the paper will highlight the potential future research directions to enhance the security of this evolving network architecture. Coming to the introduction, VANETs enhance the road safety, traffic efficiency, and passenger comfort. It enables real-time communication between vehicles, infrastructure, and pedestrians, collectively called vehicle to everything. VANETs are further enhanced by the integration with heterogeneous vehicular networks and the Internet of Vehicles using DSRC, Wi-Fi, 5G for seamless connectivity. Operating in an open access wireless media and dynamic topology makes VANET highly vulnerable to security and network attacks such as man in the middle, denial of service, eavesdropping, black hole jellyfish, flooding, etc. Despite of the numerous appealing applications of VNets, it faces critical challenges such as high mobility, dynamic topology, limited bandwidth, and intermittent connectivity. To mitigate these security attacks, researchers recommended software-defined networking integration with VNets to deploy SDN's centralized control, programmability, and network automation features to enhance security and manage dynamic network topology. SDN-based VANETs regulate the data transmission through flow tables and programmable controllers, improving flexibility and adaptability. However, SDN introduces new risk in VNets due to its centralized architecture and open flow-based communications such as single point of failure and vulnerabilities to attacks such as DOS, timing attack, man in the middle. The combination of SDN's central control with VNet's decentralized nature creates a complex security landscape, prompting researchers to explore solutions using emerging technologies like 5G, cloud computing, AI, machine learning, and blockchain to address these challenges. Here is the related review work. In reference number 12, author highlighted benefits, services, and security challenges. In reference number 17, author explored security threats and its solutions. In 18, author discussed SDN-based architecture, security threats like DDoS, and security services like authentication. In reference number 19, author surveyed integration of SDN-based VNets to enhance security and efficiency. Author also explained security threats. In reference number 20, author carried out survey on security issues and existing solutions. While SDN offers significant security benefits for VNets, it also raises security concerns which are categorized into three main areas based on the SDN architecture. Application plane attacks. These involve application threats such as false data injection, malware injection, unauthorized access. Control plane attacks target the SDN controller such as controller hijacking, topology poisoning, control plane isolation, etc. Data plane attacks, these disrupt normal data flow within the network such as flow table overflow, spoofing, packet sniffing, black hole attacks, etc. To address these security challenges, the implementation of security framework is required. Here we present a review of security mechanisms and techniques proposed by the researchers in the literature to secure the network operations of SDN-based VNets. This paper, titled SDN-based Secure and Privacy-Preserving Scheme for Vehicular Networks, was published in 2019. It focuses on enhancing security in SDN-based VNets. The approach integrates authentication, intrusion detection, and elliptic curve cryptography deployed at both the SDN and VNet layers, defending against various attacks like black hole. The framework offers improved VNet security using a hybrid approach. However, it has higher overhead in a high traffic scenarios, does not address the SDN controller vulnerabilities, and relies on a single point of failure if SDN is compromised. Future work suggests using distributed SDN to prevent failures, blockchain for secure authentication. The paper titled Consortium Blockchain-based Secure Software-Defined Vehicular Network was published in 2019, which focus on enhancing security in SDVN using blockchain-based decentralized trust management. The approach integrates trust-based security cryptography deployed at both SDN and VNet, defending against fake resource requests, malicious vehicle attacks. It ensures decentralization using blockchain, enhancing the security by trust-based allocation. However, it has scalability issues, increased network latency. Future work suggests using AI-based trust evaluation, integration
Ma'am,
of millimeter wave technology. Yes.
Ma'am, we are past the presentation time. Can we get to the conclusion, please?
Okay, ma'am. So on the basis of the limitations of all the papers, we have summarized the future research directions for research community so that they can design strong and effective security solutions for this integrated architecture. The SDN-based VNets is regarded as viable approach for tackling the existing and future challenges of traditional VNets. In this paper, an effort is made to present comprehensive review of the most prominent security mechanisms and techniques proposed by the researchers in the literature to secure the network operations of SDN-based vehicular ad hoc networks. In this paper, these mechanisms and techniques are evaluated based on technology employed, employment level, attacks defended, scalability handling, strength limitation, and future research scopes. Light on the future research security and privacy. These research directions will help the research community to design effective and robust security solutions for SDN-based VNets architecture against evolving the threats landscape. Thank you.
How does your SDN improve security in vehicle networks compared to the traditional approaches?
Hello. Yes, ma'am.
I am repeating the question.
Hanji. Yes.
How does your SDN improve the security in vehicular networks compared to the traditional approaches?
Good afternoon, ma'am. I'm the
Mhm.
co-author of this paper. Can I tell this?
Yes, you can answer.
Ma'am, in a traditional network, in VANET network, all the decision and routing decision make by the nodes. They are not centralized, managed by the network. It is called like decentralized network, in which computation overhead occur, decision can't take properly, so that there is a need of programmability, like a controller, centralized controller, to take the decision on the behalf of the node, so that एसडीएन जो है उन्होंने क्या किया कि एसडीएन कंट्रोल नेटवर्क कर रहा है कंप्लीटली वेनेट का बाय डिवाइडिंग इनटू 3 layers. Okay, then data plane only act as a forward the packets decision, but all the decision and flow controls are made by the centralized controller. But according to SDN, it is a benefit to the architecture, but as well as there is some challenges, because in a centralized SDN controller, it face a major challenge like single point failure. If we take an example of, if a controller is compromised, then there is no controller that control the complete architecture and all the nodes in the data plane that depend upon the controller to make the flow control, to make the tables update. Then all the networks goes down, and it is the major challenges. Also, SDN provide some major benefits also, like network management, security and attack detection, like deploy major IDS on SJ controller, and all the decisions are quickly managed and take easily. I hope the answer is clear now.
Yes. Okay, thank you.
The next presenter is Samir Acharya from Harvard University Institute, United States of America, and the paper title is Unlocking the Road Ahead, Predicting the Destination of a Car Within a Small Time Travel. Sir, I request you to please start with your presentation.
Can you see my screen? Hello?
Yes.
Okay. Good afternoon, everyone. My name is Samir, and today I'm excited to share our work on predicting a vehicle's destination within a short time frame, 10 seconds for us. Our project titled Unlocking the Road Ahead leverages real-time data to support smarter and safer mobility in modern cities. Here's a quick overview of what we'll cover today. We'll start with the introduction and our motivation behind this work. Then we'll dive into our methodology, share the results, and finally touch on future work limitations, and we'll conclude. This research was a collaborative effort between undergraduate and graduate researchers at Howard. I am Samir, a senior CS major, working with Dr. Arel, who is a senior research scientist in HCAI lab at Howard University, and Dr. Legan Burge, who is a professor of computer science at Howard University. So there are three major motivations behind our work. First, improving traffic safety and flow. If we can predict where a vehicle is heading in real time, cities can better manage traffic lights and reduce collisions. Second, it supports the growth of autonomous vehicles, where accurate prediction leads to smarter routing. Third, it improves the human experience by offering personalized driving assistance like better stop suggestions or detour alerts. Our goal was to build a function that takes a vehicle's real-time features like its speed, acceleration, and GPS and ranks a list of possible destinations based on how likely the vehicle is to end up there in the next 10 seconds. Unlike classification models that choose from a fixed set of options, the set of possible destinations changes every time based on where the vehicle is and how fast the vehicle is going. That's why we use a ranking approach instead of a traditional classifier. It allows us to assign an ordering to the destinations rather than just choosing one. We use a ranking algorithm called lambda mart, which is essentially useful when you care about the order of predictions and not just the answer, right? The model wants to put the actual destination as close to the top of the list as possible. To train the model, we use a metric called NDCZ, which rewards the model even more if the correct destination is ranked higher. This makes sense because in real world system, it's important that the correct guess is in the top 2 or 3 than just somewhere in the list. So for training, we use the NGSIM vehicle trajectory dataset, which contains over 11.8 million rows and which covered 16,000 trips. Each trip is segmented into 100 millisecond intervals. So we extract features like instantaneous velocity, acceleration, and geolocation and aggregate them into a 10-second window to simulate the prediction. To decide which destinations are even possible, we calculate how far the vehicle could realistically go in the next 10 seconds. This depends on the vehicle's current speed. But the rows are in 100 millisecond intervals. So we need to aggregate the instantaneous velocity and assume that it's constant and use that to draw a radius around the current position. We did explore modeling acceleration or using upper bounds to estimate reachability, but our statistical analysis showed that the vehicle velocity varied unpredictably. The autocorrelation graph had too many, meaning we couldn't rely on patterns in speed or acceleration. So we chose a constant velocity. Then we pull all reachable destination nodes from OpenStreetMap within that radius. That becomes our candidate set, the nodes that the model is allowed to rank. And the core training objective is to minimize the NDCZ score, which ensures that the model ranks the correct destination at our top, ideally within 2 or 3. Our optimization process involves comparing predicted and actual rankings with the final destination treated as the ground truth. We use light GBM for this task due to its speed and ranking capabilities. So this slide highlights our key result. Our model achieves 100% top 2 accuracy. That means the actual destination is always among the top 2 ranked predictions. In comparison, other methods like random walk or distance-based sorting requires much higher values of K to reach this level of accuracy. Also, to evaluate the spatial accuracy, we use the Haversine formula to calculate the actual distance error between predicted and true destinations. We observe near zero errors when the actual destination is a part of the candidate set, but when it's not, the errors can vary anywhere from 100 to 200 meters. We also examined angular deviation between predicted paths just to prove that we're not just predicting in a straight line, because that would be preliminary. Our model performs incredibly fast with an average prediction time of just 0.0004243 seconds. This low latency holds even as the number of candidate nodes increases. So when a vehicle is moving very fast, making the model suitable for real-time applications like autonomous driving or live navigation support. One major limitation is that we depend on OpenStreet data, which may not always have fine-grained node coverage. It's not as good as the Google Maps data. This sometimes causes errors when a vehicle's destination isn't near a known node. Another limitation is that we only used a subset of the full dataset due to our computational limits. In the future, we want to train on the entire dataset and explore more accurate modeling of vehicle dynamics to reduce prediction errors further. To summarize, we presented a novel destination prediction model that combines real-time data with a ranking-based machine learning approach. We achieved near instant predictions with high accuracy, outperforming existing methods. This work opens the door for better navigation systems, especially in high-density urban areas, and contributes towards safer and more efficient transportation systems. Thank you. Any questions?
Yes, good afternoon.
Good afternoon.
Can your approach be integrated in the existing navigation or smart mobility system?
Almost all of the existing approaches to this problem are trajectory prediction, so they did not focus on a final destination prediction. And trajectory prediction means using historical data, which would require some sort of LSTMs or by LSTMs to process. This should make the model heavier, less interpretable, and slower. So we didn't really go with that, but it can be used, yeah.
Okay. And how does your system be ensure the data privacy and user security?
This model is to be ran locally, so we have the trained model. It will run on the edge devices itself, so the data does not have to leave the phone or vehicle. So they are private, yeah.
Okay, thank you.
Thank you, sir. Now all of the presentations are done. Sharmila ma'am, are you there in the meeting? Please give me a response.
Yes, ma'am.
Ma'am, you can present now. Yours is remaining. Ma'am.
Okay, okay, ma'am. Okay. Ma'am, can you able to view, ma'am?
Yes, we can see.
Can you able to hear me, ma'am?
Yes, ma'am.
Okay.
Hello.
Ma'am,
Ma'am.
ma'am, 1 minute. 1 minute.
Yes.
Okay. Shall I start, ma'am? And enhance, ma'am?
Yes, you can start. You can
Yes.
Okay. An enhanced bearing fault diagnosis method based on deep fault diagnosing adversarial network presented by Sharmila, and the co-authors are Anuradha, Armay Shaini, and Sita Raman. Introduction in modern industries, early and accurate bearing. Ma'am, I want to minimize the screen, so my slide is not visible for me. 1 minute, ma'am. Okay, ma'am. In modern industries, early and accurate bearing fault detection is crucial, time consuming, and breakdowns are not identified in a fast pace. So manual inspections are time consuming and impractical. Vibration signals commonly used in condition monitoring are noisy and require external sensors. Traditional method using machine learning and frequency domain. Initially, they are using the traditional methods, but now in my proposed system, I am using deep learning model and CNN for classifying the faults. And to address this, we propose a fault diagnostic adversarial network. And here I have used GAN to increase the size of my data set. And I am using CNN to classify faults into inner race fault, outer race fault, and roller fault and normal condition. I'm going to classify it into 4 categories. And here I have referred few of the literature survey papers. And in the first paper, they are using vibration-based health indicators and machine learning signal processing modeling. And in the second one, they are using fault detection in induction motor using machine learning methods. And in the second paper, they have used statistical feature extraction and machine learning classifiers. And in the fourth paper, they have used fuzzy sliding mode observer plus residual signal analysis and and in the fifth paper, they have used DWT for feature extraction, and they have used RF and XGBoost for fault classification. And in the sixth paper, they are using skewing transform plus CNN using envelope time frequency representation. And in the seventh one, they are using CNN with noise filtering. And in the eighth one, they are using GAN to map noise distribution to real vibration data. So the research gap is the manual inspection of machine health is costly and time consuming. The current method lacked the ability to detect fault at an early stage, and usage of imbalanced data set. So we need to provide an intelligent automatic diagnostic system and a method to improve the accuracy as well as the efficiency. And the objective is, here I'm going to develop an intelligent fault diagnostic system to generate synthetic bearing fault data to classify the bearing faults using deep CNN model. So this is the methodology. The raw signal data is converted to vibration signals, and the vibration signals are then converted to the short time frequency transform, and the short time frequency transform finally converts the image to a spectrogram image, and it is stored in the data set. And the normal image is stored in one folder, and the roller bearing outer ring fault and inner ring fault failures are in separate folders. And after that, if the size of the data set is very small, I'm going to use a GAN model to increase the size of the data set. How the GAN model works is, it works in two fashion. One is generator and discriminator. The generator is going to generate fake images, and the discriminator is going to check whether the generated image is fake or real. So at one point of time, the generated image will come to a real image. So the discriminator can accept that as a real image, and it is going to store in the data set. And after that, for classification, I'm sending it to a CNN classifier model. And this is the number of layers used in my CNN. One is initially the inputs are resized to 250 cross 250, and I have used 4 convolution layers, and followed by batch normalization, ReLU activation, and max pooling layers. And finally, for classification, I'm using 3 fully connected layers. And by comparing with the existing method, I have achieved an accuracy, slightly a high accuracy when compared to other methods like SST, DCN, and SK based CNN. I have achieved a slight high accuracy when compared to the previous methods, and but the sensitivity and the specificity is high in my proposed method. So conclusion, here I have developed deep fault diagnostic adversarial networks to increase the accuracy and robustness of bearing fault diagnosis in induction motors. And STFT based, here I am giving this spectrogram image as an input to the CNN model to extract rich features from the image. And so I have used a GAN model to maintain the balance of the data set, and CNN classifier to classify the images into correct category. In future, I'm going to deploy deep FDAN for real-time fault diagnostic in industrial systems, and apply explainable AI to interpret model decisions and enhance robust against noise and limited data, and extend to other fault types like gears and shafts. Test across multiple data set for better generalization. These are the references. Thank you.
Good afternoon, madam.
Good afternoon, ma'am. Can you able to hear me?
Yes.
Okay.
Could your method be generalized to the other type of industrial fault diagnosis?
Yes, ma'am. Yes, ma'am. It can be applied to any type of industrial faults, ma'am. But we need the data set. If the size of the data set is less, we can use GAN to generate a synthetic image, and we can work on it, ma'am.
Okay. And what challenges did you encounter when you were
Ma'am,
implementing?
till now, only the data set issue I faced, ma'am. Other than that, after using GAN, the size of the data set is increased, but it is time consuming, ma'am.
Okay, thank you.
Okay.
Thank you, ma'am.
Thank you.
Okay, that was the last presentation that we had. Now we'll proceed to the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters will be given their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chair. Lastly, I would like to thank both our session chairs for wonderfully chairing this session, Dr. Aneri Kilol Pandey and Dr. Kalpana Naidu.
Yeah, thank you.
A token of appreciation to the chairs on behalf of Team ICTIS 2025. Thank you very much for your valuable presence. Now, lastly, before ending this session, I request all the participants along with the session chairs to please turn on your cameras so that I can take a quick snapshot of today's conference. We'll just wait for a half a minute to let everyone turn on their cameras. Okay, I've taken the snapshot. We can end this meeting now. This was a great session. Thank you, everybody.